Hello and welcome to 7.5 Systems of Inequalities. What we're going to do today is we're going to sketch the graph of inequalities in two variables, solve systems of inequalities, and use systems of inequalities in two variables to model and solve real-life problems. Remember, at any time, if you're falling behind, you can always stop and pause the video and play the catch-up. All right, so you've done this before. You've graphed an inequality. You've done where you've graphed it. You put an equal sign in, you graph the graph, and then what you do is then you pick a test point. So here they're picking 0, 0. If 0, 0 works, then you shade the area where 0, 0 is. If 0, 2, they pick 0, -2. That did not work, so they don't shade that area. So just to review, if I had something like x squared plus 1, y is greater than or equal to x squared plus 1, you're thinking of it as though y is equal to x squared plus 1, which we know is a parabola that shifted 1 unit up. So I'm going to sketch that very quickly. 104. I have this parabola. Just to review, if it's equal to, the line is solid. If it's just greater or less than, remember you have a dashed line. Then I would do my test points, and let's say pick the test point 0, 0. I put that into the original equation, so 0 is greater than or equal to 0 plus 1, so 0 is greater than or equal to 1. That is false. So here's where 0, 0 is. That was false, so to solve this inequality, I would shade everything that was in the opposite direction, so I would shade what's inside the parabola. You've done that before. What we're going to do to make it a little bit more challenging is we're going to make it a system, which means we're going to bring in the second equation. So I have y is less than negative x plus 3. I'm going to think of that as though y is equal to x, negative x plus 3, y-intercept of negative 3, slope of negative 1, y-intercept of 3, sorry, 1, 2, 3, slope of negative 1. So on this time, though, it's because it's just less than, and I should have done that less than, it is going to be a dashed line and not a solid line. So here I put in a dashed line. I'm also going to test the point 0, 0. So I'll do 0, 0. So where 0 is less than 0 plus 3. 0 is less than 3, which is true, so I'm going to shade everything towards that direction. So the answer to this system would just be this little area that's in between the parabola and the line. That's what we're doing today. And as you can see, it wasn't really that difficult. So again, you're going to have more than two equations. This was an example in your book where we had 3 inequalities. So each inequality is done. As you can see, some have dashed lines because they're just, some are just dashed lines because they're just less than or greater than, and some are solid lines because they were less than or equal to. We plot those 3, and then the other thing you're going to have to do is you're going to find the places where those lines intersect to come up with those intersection points, and these are called the vertices. And those will become extremely important in the next section. So get in the habit of identifying and labeling your vertices. So here, what I've done is that I've already graphed it for you. I have x plus 1. I just graphed the lines. I have x plus y is greater than or equal to 1. Negative x plus, so this one is this equation right here, is this line right here. And now I'm going to do the test point 0, 0. If I do the test point 0, 0, I have 0 plus 0 is greater than or equal to 1. That's false. So I would shade away from 0, 0. So I'm going to shade in this direction. Then when I do the next line, which is this negative x plus y is greater than or equal to 1, that's this line right here. I test the point 0, 0. So I'm going to have 0 plus 0 is greater than or equal to 1. 0 is greater than or equal to 1, that's false. So I shade away from the 0, 0. So I'm going to shade up this direction. So far, the only place that's going to be a solution so far is this area up in this region right here. And the last equation I have is this y is less than or equal to, which is a horizontal line. I test 0, 0. Big old mess. I tested, so I'm going to have 0 is less than or equal to 2, which is true. So I'm shading in the direction of 0, 0. So I'm going to shade down. So the only solution, the solution to this system is going to be this teeny tiny little triangle right in here. That's the only thing that's true for all three of those systems. And then I would identify the vertices. And if you look really carefully, I tried to graph neatly so I could see them. My vertices are going to be 0, 1, 1, 2, and negative 1, 2. And that labels these 3 points right there. So now I have this one. You will have graphs that aren't functions, so you'll have to get used to that. This line right here, I already graphed for you. This is this line here. The test point is 0, 0. So I'm going to have 0 is less than 2 minus 0, so 0 is less than 2. That's true. So I'm going to shade in the direction of 0, 0. The only time I would not use 0, 0 is if 0, 0 is a point on the graph. Then you can't use it. Oh, my bad. This should be a dashed line and not a solid line. I am so sorry about that. Let's correct that. You know what? Take off. We do that. Now, let's make that line go away. Let's bring our dashed line. So, you're not very neat anymore, but get the gist. And then this is not a function. It's not obviously not a function because every input would have more than one output. This is not a function, but if you're not sure how to graph it, then you can set up an XY table. And if I put in like 0 for y, x would be 0. 1 for y, x would be 1. If I put in a negative 1 for y, it's where I'm also going to be positive 1. You should be familiar with the shape. It's like a parabola that lays on its side. So just something like this. It is also going to be a dashed line. I cannot use 0, 0 because 0, 0 is a point on the graph, so I cannot use that. So I'm going to pick another point. Let's say pick a point way out here, 1, 2, 3, 4. Let's do 5, 0. So I'm testing 5, 0. That's my test point. When I put that in, I'm going to have 5 is greater than 0 squared. So 5 is greater than 0. That is true. So then I would shade the area inside the parabola. So I'm going to go inside the parabola. And the only solution to this system is going to be the area right in here. And that's going to be a little trickier to find the vertices. We can do it. Sorry about that. I forgot to clean up my mess when I was practicing. So here, both of these are going to be dash lines because it's just greater than or less than. So when I graph these, I'm going to have a y-intercept of 3. And then a slope of 2. But now I know that it has to be a dashed line, so I'm going to bring out a dashed line. I'm going to test 0, 0.
Good afternoon, friends. As we prepare to end this school day, I do have a couple of announcements that require your attention.
Okay, while Mr. Weller was doing announcements, I went ahead and finished the graph. So I had the 2 graphs. I didn't do any of the shading. When I shade the first one, the y is greater than 2x plus 3. And I do the shading for this one. It's going to end up being this area up here. When I do the shading for this graph, and I test the point 0, 0 is going to be 0, is less than -1. That's false, so I'm going to end up shading here. So what happens is I have two parallel lines. I know the parallel because they have
Michael Petranzio, please go to room 120. Michael Petranzio to room 120.
I have the same slope. So I have the same slope, so I know the parallel lines, different y-intercepts. So I know there's no solution to the system. You're going to have to help me. And then, so there's no solution. Okay, and then the last, when I have this one, I have a parabola. It's going to be a dash. I have a parabola. So I don't normally do your graphs.
Sarah King, please come to the office.
So I have a parabola, y is greater than or equal to, I cannot use this point 0, 0, so I'm going to use a different test point. Maybe I use 0, 1, that would be this point right here inside the parabola. So I'm going to have 1 is greater than 0 squared, so 1 is greater than 0, that's true. So I'm shading inside the parabola. And then x is greater than y plus 2. And this dashed line, very best drawn. Test point 0, 0. 0 is greater than 0 plus 2. 0 is greater than 2. That's false. I'm going to shade above that. So it's going to go like this. And when you have something like this where I know an area that I'm doing, it's going to be inside the parabola. It's going to be inside the parabola, but above that line. Ooh, shouldn't have done that. So it's going to be this area up here, but there's no end. It's going to keep on going. So that's what's called an unbounded system, because I won't have vertices on the top part because it doesn't end. So that's called an unbound system. Now let's go on to, and then here's an example of another one where I have two parallel lines, so I'm not going to have a solution. So it's just the same as before. The answer to the question is there's no solutions. And this is and the other thing that can happen with an unbounded solution set. In this case, I have like this wedge, this infinity wedge, so it's going to be unbounded because I can find the one vertex of 3, 0, but I cannot find any other vertices. Okay, important life lesson, never try and record at the end of the day. We now know that. Okay, the last thing I have to tell you about is the application. So one of the applications is for economics. You've heard about supply and demand curves before, and this is an example of a supply and demand curve where we can find what's called the consumer surplus and the producer surplus. So what this means is on this graph, what I have here is I have this line here.
Please come to the office.
I have this line here, which is the demand curve. So that should make sense to you. The higher price, the fewer the people are going to want to buy it. But as the price goes down, then the number of units that are sold will also increase. So this is going to be your demand curve. Going sort of the opposite, a producer is going to be more willing to make more units. As the price goes up, the producer will make more units. That should make sense. So, okay, so now I have these two places. This place here where they intersect is called the equilibrium point. In other words, that's a point where the demand curve and the supply curve intersect. So that's like the ultimate price and the ultimate supply. When you have this area up here, this little triangle here, this is going to be what's called the consumer surplus. And what the consumer surplus is it's what the consumers would have paid above what they actually paid. In other words, there are people that would have paid this price, but they didn't have to because they ended up paying this price here. So this is the consumer surplus. Down here, this is going to end up being the producer surplus. So in order to find out what the consumer surplus is, we form this triangle. See this triangle? So we're just going to do like a 1/2 area. We're just going to do 1/2 the base times the height of that triangle. And that's how you're going to find that area. And so let's just do a number name, make it easier. So here I have the consumer surplus and demand. The consumer surplus and producer surplus is supply and demand equations. So P stands for price, X stands for the number of units. So I put both of those equations into my calculator, and when I did that, I got this, which I can see my second equation, and I can't see my first equation. So I just want to go through how I would go about finding that. So when I go back and look at this equation, I can see that my y-intercept is 81. So I go in here and I change my window, and it doesn't make sense to have negative values for my units. It doesn't make sense to have negative values for my price. I said that my X max I'm not sure of, but the highest my price can be is 81 because that would be my y-intercept. When I do that, I can see that, but I can see that eventually they're going to intersect, so I need to increase the X. So I go out here, I change my window settings, and let's say I do 100 for my X. I can see I'm getting closer, but not close enough, so I keep on playing with this. Let's say I do 150. And there I can have my two equations, and I need to find this equilibrium point, so I'm going to find the intersection. So menu, analyze graph, intersection, lower bound, upper bound, and here it tells me the 120 and 15. So I am going to copy that and bring that over here so we can just put it here. We can deal with this graph instead of that graph. So what I'm going to do is this is a consumer, the blue line is the consumer, and the red line is the producer. So when I go to find this area, I'm gonna sketch these triangles. So I'm going to bring this over here, and that's going to intersect at 120. So to find the consumer surplus, I want this triangle here. So the base of this triangle would be the X coordinate, or 120. So the consumer surplus is going to be 1/2, 120 times the height of the triangle. Well, here it intersects at 15, and then here it's 81. So the difference between 15 and 81 is 66. 66. So I'm going to multiply that. Calculator. And I'm going to get $5,940. And then do the producer surplus. I'm going to do 1/2. The base of my triangle is still, base of my triangle would be 15. And the height would be 120. I guess that would be the same here. These two would actually flip, but it doesn't matter. I'm multiplying. And when I do that, I get 900. And that would be units. Okay, sorry for all the interruptions. There is a quiz on Blackboard, so you go on Blackboard, answer those few questions, and then this is the homework that I expect to see in next class. Hope you have a great weekend. Thanks. Bye.